Hi, welcome everyone. In this series of videos, we are going to learn programming concepts of ARM 7 using Keil Microvision. We will be writing programs for LPC 2148 microcontroller. In this video, we are writing a program to multiply two 16-bit numbers. Whenever we start writing a program, we start with directive called as area. First, we need to define area within memory. Area directive specifies the memory locations where the program or data resides. Then, give area name followed by the key attributes. The valid attributes are code, which contains machine instructions, that is, the area includes only programs. By default, the code area can be read only. Next, it can be data, where the data area includes only data but not instructions. By default, it can be read-write. The usage of the area directive is shown for an assembly language. Example is area, which is a directive, followed by area name, example, then code, that is code memory, which is read only. The program may also have the entry and end directives. So entry directive is a code entry point, or it is a point in the code where the program execution should begin. And it is ended with the directive called as end, which indicates the end of the file. End is a directive which informs the assembler that the end of the source file has reached. Next, let us start writing a program, which is an assembly language program, to multiply two 16-bit numbers. To start with, first, we need to define an area. Let us take, we have a memory. In that memory, we can take some part and make this as memory area. We can give any name to this memory. But as we are writing multiplication program, name of that area can be given as multiply. So why this area is used? What are we writing inside this area? In this area, we are writing a code. That is, code is a set of instructions. Next, what type of memory it is? It is read-only memory. Here, we multiply two 16-bit numbers. First, take a 16-bit number to a register called as R1, which is equal to 6400 in decimal, whose hexadecimal equivalent is 1900H. Similarly, next to take one more number to a register R2, which is 3200 in decimal, and in hexadecimal, it is represented as 0C80H. Now, we have taken two numbers or two values in two registers. Next, multiply these two values and store in another register, which is called as R3. So after multiplying the values of R1 and R2, we get the value of 1388000H, which is hexadecimal multiplication of R1 and R2 into register R3. Next, let's see how do we write a program. So to write a program, we have considered the directive called as area. To start writing any assembly language program, we start with the directive called as area, given by the area name. It is multiply, where we are writing into code the set of instructions. The code can be only read only. Next, we take the entry directive, which indicates the entry point for a code. Next, the start, which indicates the start of execution of instructions. Entry and start are the labels. Next, we have the first number, which is moved into register R1. After execution of this instruction, R1 is equal to 6400, which is decimal. Next, we are taking the second value, which is moved, which is written using a move instruction, that is move R2, 3200. R2, after the execution of this instruction, R2 will be having 3200. Next, we need to multiply the values which are moved into R1 and R2. So we use the instructions multiply R1 and R2 and store the result in R3. Next, we can stop writing instruction using NOP, that is no operation. Then end of the program is written using the end directive, which indicates end of the code. Now, let us see the execution of this program using the Keil Microvision software. To write any program, we need Keil Microvision software. So now I have opened the Keil Microvision software. To create a new project, go to the project, select new Microvision project. It will open a new project window. And we need to save this file. To save this, we can select any folder where we want to save this file. So first, you can create a folder on a desktop and then give the name and then save this file. So now I'll be saving this file by giving the name as multiply. Multiply. Save this on a desktop. Click on save. Next, it will ask to select the target device. So our target device is LPC 2148. That is ARM 7 microcontroller. So select 2148 from this. It will show the specification of the ARM 7 microcontroller. Then click on OK. Select this and click on OK. Next, it will ask to start a startup file. For all assembly language programs, click on No. Now you can see we have created a target which is having a source group. Now to write a program, select File and click on New. Here we get a blank window. Save this file with .asm, multiply.asm. Extension is ASM for assembly language programming. Once it is saved, we need to add this file for source group. To add, right-click on source group, add files to source group 1 and search for the ASM file. Here, click on the ASM file and select the ASM file. So I'm considering this .asm, add and close the window. So we can see here in the source file, we can see that in source group, we have added multiply.asm file. Now, let's write the same program, what we have seen. So we have written the same program which we have seen. So in assembly language programming, we should write the directives and instructions after a tab. Write the directive and instructions after a tab. And the labels, that is entry and start, are written without any tab. So here we have two labels which indicates the start of program. So directives and instructions are to be written after a tab. Now save the program, click on save. Next, build the target by clicking on build target icon. Once it is built, it will show any errors or warnings. Here, since we don't have any errors or warnings, it is showing 0 errors, 0 warnings. Once we build a program, we should debug this program. To debug, go to the debug icon and click on Start Stop Debug Session. Click OK. On the left-hand side, we can see all the registers. So all the registers are having a value 0. This arrow indicates we are running this instructions. Now we can execute the instructions step by step by clicking on the step-by-step execution. So when you first click on this, R1 is having a value 1900. That is R1 6400, hexadecimal equivalent is 1900. Next, we have this instruction, that is R2 is having 0C80. Next, multiply R1 and R2 and the result is stored in R3, which is 1388000. This is how we write a program and execute. To come out of this debug session, go to debug and click on stop. Thank you.